In this video, I'm going to go over how to find descriptive statistics of a set of data using a frequency list. Okay, I've done some similar videos using an a TI-84 calculator, a graphing calculator. In this case, I'm going to use a TI-84. I don't believe I've done one with a frequency list. This works fine, especially when you have a large number of items in your data, and quite a few of them are repeated. So really advantageous, especially when you have, say, hundreds of values or thousands of values, and you want to go through and create a table. Okay. Here I left out, say, a third column where I could have a tally, where I would go through all my data, especially if I have a large. Here I don't have that many values. Okay, so basically I have one data value is 48, it's repeated 9 times. One is 55, it's repeated 3 times. 63 repeated 8 times, and so on. But you could have, like I said, hundreds or thousands of data values, and a lot of them repeated. Now, if you don't have that many and just a few are repeated, then you could just forget about the frequency and just list the data. So here I'm interested in finding descriptive statistics. This would be, say, measures of central tendency, which of course are average, such as the mean, which is the one that's used quite a bit in statistics, the median. There's also the mode, another type of average. The mode doesn't have really any significant statistical value. It's just the most frequent data value that appears. So in this particular list here, the one that appears more frequent, you can see here, is 67. So 67 would be would be called the mode. Okay, and you could have more than one mode. Okay, say 75 is repeated 11 times, so this would be a bimodal distribution, and so on. So what we would do on your calculator, and again here I'm using the TI-84 graphing calculator, is we would go to Stat, and then one is Edit. When we want to calculate, we go to Calculate, and we got to run some tests. For example, t-test, we go to Test. So here I want to first enter the data, so I hit number 1 is already highlighted, so I just hit Enter. And then since I have a frequency list, I'm going to use 2 columns. I've already entered the data in column 1, or L1. Okay. Now, if you didn't have that many values repeated, you could just go ahead and use 1 column and just list them. So if 48 gets repeated 3 times, you put it down 3 times, and so on. But here we have some large values. Most of the items are repeated. Okay, if it's only repeated, if it's only one item, then we put a 1. So here in this particular case, then the 48, I'm going to put the frequency. It's 9 times. So 9, and then Enter. The 55 is 3 times, so I hit 3 and then Enter. The 63 is 8 times, so Enter 8 and then Enter. 67 is 11 times, Enter it. 75 is twice. 78 1 time. 85 is 5 times. Okay, and then we go to Enter there. 85 is 5 times. 86 is 3. Okay, 91 is 7. So again, we enter that, enter the value, then hit Enter. 98 is just repeated 1 time, so enter, put a 1. Enter, and then 99 is 3 times. Okay. Now again, I don't have to use the frequency distribution here, frequency list. I could just go ahead and just repeat the values over here in 1 column. Okay. But if you set up your table nicely, this works out pretty good. Then I would just go to Stat. Okay, I want to calculate, like I said, descriptive statistics here, and I only have 1 variable here. Okay, so I hit Enter, And the default column we'll be using is L1. Now if you weren't using the frequency list, then you would just go to calculate here and hit enter. But since we're use the column for a frequency, then I have to enter L2 over here. So I'm going to scroll down here and then hit the second key, because over here is L2. It's right above the number 2 on your keyboard here. So hit second and then 2, which gives me L2. Okay, so this tells me then that my main data is at L1 and the frequency list is in L2. Go down to calculate, hit enter, and there I get the data. Okay, so this tells me that the mean then is 71. That's the arithmetic mean, 71.33. You can round it off accordingly. Okay, 71.34. You want it 2 places. The rest of the data that gives you here, again, we're not going to use here. The next one tells me summation of X. This simply adds up all the values in the distribution. And that comes out to 3,781. Again, the next one we're not going to use. Well, we don't need it for this calculation here, but it's the sum of the squares of the data values. So if you take each data value and square it, add it up, you get this value here, 283,563. Again, that could be used in some other formulas. The standard deviation are the next two. So the first one is what's called the sample deviation, and that simply measures the extent to which the data values deviate from the mean. Okay, so the mean is 71. Okay, so the larger the standard deviation is, basically the more spread out the scores are. Okay, again, it measures the extent to which the data values deviate from the mean. The second one, sigma sub x, is also standard deviation, but it's a standard deviation for the population. Okay, you might be doing a study of, say, the freshman class at some university, and you might just want to take a sample. In that case, you would use the value given by S of x. If you want to test the whole freshman class and not use a random sample, then you would use the second deviation, standard deviation. You can see they're pretty close, 16.307, 16.153 if you round off there. And then, of course, the next thing that the calculator provides is the frequency. So if I add up the numbers in the frequency column, I get 53. Okay, so basically if I were just to list the scores all, I would have 53 items in that list. Scroll down a little bit. Okay, next thing it gives you the minimum value. Okay, so the smallest value in the data is 48. Okay, Q1 is the quartile, first quartile. It gives you 63. The median is 67. The median, I guess, is an average. If you have your data arranged in ascending or descending order, the median is basically your middle value. Okay, so if you have an odd number of values in the distribution, it's just going to be the item right in the middle, assuming you have it in ascending or descending powers. If it's an even number of values in your distribution, then you simply take the middle two and find the average of those two. In other words, add those in and divide by 2. So in this case, the median is 67. The mode, as we mentioned earlier, is also 67. It doesn't give you that here, but that one's easy to find if you have it set up, especially in this table form. Okay, the third quartile value is 86. Okay. Maximum value in the distribution from the table is 99. It occurs 3 times. So that's some useful information you can use if you want to just take some data, no matter how small the data, how large, into the values. You don't have to use the frequency list, but it's advantageous, especially if you have a lot of values repeated, a large number of data items in your distribution. So you can use this particular data to analyze your sample. You're a teacher, for example, you want to know how your kids do, how your kids did in a particular test. You know, you find your array of average arithmetic mean, find the standard deviation to find out how dispersed the scores were. Okay. That will conclude the video. Again, like I said earlier, I have made some videos using 83 calculator. This one gives you a little bit more data here that you can use in other statistical analysis. Okay, so thanks for watching. We'll see you in the next video.